Thanks, Romy. Thanks for the opportunity to speak. I learned a while ago that I have a tendency to say really stupid things, and then David Mobley tweets out all the stupid things that I said, so I have to be careful. Yeah, like last time, like, you know, I said the PDB file format is an abomination, which it is. You know, and all of a sudden on Twitter, it's like, Tom Wilson said PDB format is an abomination. So, yeah. Thanks, David. Anyway, so this is going to be kind of a rant. So if you don't like rants, you know, the waves look really nice out there. Anyhow, so I've done 5 of these now. So I did 3 D3R challenges, and I did the first 2 ACS TDT, which was sort of a similar thing that was originally spearheaded by Hanneke Janssen at Novartis. And you can see these are spaced out just enough that, one, I forget how much work this is, so that when Romy and Mike ask me if I want to do it again, I'm like, oh yeah, sure, yeah, no problem. And then they're also spaced out enough that it's just enough time for me to forget everything that I did before, and I have to reinvent the whole thing. So, you know, and so I've been the external evaluator. So this is sort of a breakdown of my work. I spend most of my time dealing with the fact that we give you guys structures with bond orders and you throw them away, give them back to us without, and make it a whole lot more work. But actually, it keeps getting easier, and I have to thank Connor and Syed and Schwai, actually, who did a lot of the original work. So this is a lot easier. And then, you know, I compare my results with the folks at UCSD, and they're always right when there's a difference, and we figure out why there's a difference, but it's usually minor things. And then based on the quality of this presentation, you'll see that I don't spend a lot of time making the slides. Sync it all up on the morning of. Yeah, so this is sort of the way that it works. I evaluate, the folks at UCSD evaluate, we compare our results, so everything's completely independent. We make sure that we align on these, and then we send them to all of you. So now we're going to start talking about things that bother me a lot. One, you know, if you read the literature, it looks like all the stuff that we're doing is a solved problem. It all looks so much better than the results that we're getting in these blind challenges. So a lot of this is, you know, me venting here, and this is some of the things I keep sending these emails to Kenny Murs saying, Kenny, why are you publishing this crap? You know, I hate this, I really do. But I want to start talking about. Okay. No, I mean, I really hate this stuff, but I'm hoping that, you know, most of the people that review this paper, these papers are probably in this room. So let's try to agree on what the criteria is and what constitutes good, okay? And let's really try to push back on some of this. I mean, you know, you take a look at this and it's like, okay, people are getting these great correlations, but they're getting the great correlations because they're using a completely wrong data set that spans 10 logs, right? It's just wrong. And let me point out a few reasons that I think that this is wrong. So you can see, you know, this is from a very recent paper in JCIM, yet another convolutional neural network, and it looks great, right? I mean, they're getting Pearson R's of, you know, and I hate when people use R rather than R squared. I think it's dishonest, but again, it's just me. But you know, it's just wrong because, you know, if you take a look, okay, this is what we're getting in D3R, right? We're getting things, you know, the best are around 0.5, 0.6. Now, these are a little lower than what you saw yesterday because I left the greater than 10s in there. But still, we're not doing as well as what's reported in the literature. So, you know, I'm hoping that we can try as a community, and, you know, Kenny told me I have to write a paper about this because he's sick of hearing me bitch. So I'm going to do that. But here's a few things that I think we should agree on. One, what constitutes a reasonable data set, right? So, you know, I appreciate the people who put out PDB bind. It's great. You know, I mean, they put a lot of work into this. But I just don't think a data set that spans 10 logs is realistic, right? That's not what we do in drug discovery. In drug discovery, we're typically dealing with data sets that span 4 to 5 logs. So, you know, if you take the same data set, So this is another, this is actually a solubility data set, but it spans, a ridiculous dynamic range. It's got everything from methane to cholesterol in the data set. So of course you're going to get a great correlation. Now, if you take the subset of that that's relevant to drug discovery and you do the, you calculate the same correlation coefficient, it goes from 0.7 to 0.2. So, I think we need to be realistic about what we're doing and use realistic data sets. And that's why I like challenges like D3R, right? So this is the cathepsin S data set that we used for D3R. And you can see that that's realistic. Span 3 logs, couple of compounds up there and 4 logs. But this is the reality of what we live with in drug discovery. And I think, as reviewers, we need to push back when somebody's saying, great, I got this great correlation. It's like, okay, that's fine. Now, go grab one of the D3R data sets. Show us what you can do. Okay, here's another thing that really bothers me, how data should be reported. I hate this. Please stop doing this, okay? Please stop cramming so much data on one plot. I mean, this is, Edward Tufte would just run screaming from the room. If you saw this, this is meaningless. It's horrible. Please stop doing this. I'm even going to throw my friends under the bus. Mill, Lisa. Apparently, so I thought that the Schrodinger people were responsible for this abomination because they put that into their FEP paper. But apparently Greg Warren is responsible for this.
We've done that.
Okay. But I think the better way to do this is just to trellis your data. Because when you trellis it, I can actually see where the trends are, and I don't have to try to do a magic eye picture to pull out the individual data sets. Evaluation metrics. So this was from a paper that was in JPhys Chem a few months ago. Now, JPhys Chem doesn't typically publish papers like this, but, which has a correlation between measured and calculated values of 0.69. What does that mean? Is that Pearson, Spearman? I read through the paper like 4 times. I have no idea what correlation means. Then, to make matters worse, there was no supporting information. So I couldn't actually grab the data myself and see what they were talking about. So, I think we're not going to agree on what the best metric is. So just put them all in your paper, put Pearson, put Spearman, put Kendall, just put everything, you'll make everybody happy. Put the mean, put the median. It's not hard to do, but please don't, if you see a paper that just says correlation, please reject that paper. I think another thing, there was this great paper that some of the guys at Abbott published almost 10 years ago now. And I still don't see this reference. This paper should have like more citations than any paper in the current literature, because it's great. Because what they were saying was, let's take a look at what the maximum achievable correlation is given experimental error. And it's a really simple process. So you start with the experimental data, you add Gaussian error to it, and you look at what the correlation is. And report that along with the correlation that you got from your prediction. And sometimes, the maximum achievable correlation is very high. So this is from one of the data sets from the first D3R challenge. So you can see that, you can get, given the error, you can still get correlations up, around 0.95. So that's great. But there are other data sets where the best you're going to be able to do is 0.6. So I think it's important to look at that sort of thing. So hopefully, to make this a little better, Cartoon Pat has put together an open source software package that I call the Molecular Evaluation Toolkit. So a lot of this stuff is in there now. So I've got code in there for doing maximum achievable correlation, for doing confidence intervals around this. If there's things that I don't have in there, please, fork it. and I said fork, David. Just, you know, fork the code, add stuff in, or, you know, send it to me and I'll put it in. But I'd really like to get to the point where we can make this very easy for people and make it easy for everyone to go ahead and evaluate their methods the right way. Statistics for comparison. So here's another thing that I see way too often in the literature that bothers me a lot. So in this particular case, these guys were looking at different ways of doing conformational sampling. And they said, well, here's our method. You know, we got a correlation of 0.72 to 0.79. It's way better than the other method that was, you know, 0.61 to 0.74, right? But I think the thing we have to remember is, you know, so they put up this table, you know, here's their method, the third one over, that had the highest correlation, yay, we win, right? But I think the thing we have to remember is that there's an error associated with a correlation coefficient. This is also in METK, calculating this, but there's an error, and that error is a function of both the correlation and the number of data points. So what I'm plotting here is a number of data points, and then we're plotting out the 95% confidence interval for, you know, R ranging from 0.6. So you can see that at 0.6, you know, if you've got a small number of data points, your correlation could be anything. So you really can't make those comparisons. You know, when you get down to the bottom right and you've got 0.9, then you're very confident and in your correlation, even with a relatively small number of data points. So it's important to calculate the confidence intervals around these correlations. And I think, again, if you're reviewing a paper, insist on this. So if you take a look at that same data set, you know, it's a relatively small number of data points. So when I put error bars on these, they're all the same. Next up, what constitutes a null model? So, you know, I see these papers all the time where we ran our method, here's the correlation that we got, it's much better than molecular weight. Yay, we win. But there's more information in that data set than molecular weight or log P, right? There's more there. So, you know, here's my suggestion for a really simple null. So I took this PBbind core set that everybody tends to use. I'm sorry, it's not PBbind, it's the Chinese one, right? PBbind is yours. Oh, okay, PBbind. Okay, I don't want to badmouth Mike. No, this is the Chinese. There you go. So, you know, here was my really simple null model. I consider this a null model because it took me 5 minutes to do. So I generated RDKit fingerprints for the ligands. I trained on the PDB-bind reference set, which is about 4,000 molecules. I then predicted on the core set, you know, and that's the correlation I got. So it's a lot better, actually statistically better, than what you would get from molecular weight. So, you know, I think we just need to think a little bit about what your null model is. And I see far too many papers that are published that have no null. So I think, you know, if you're a reviewer, you get this, you go back. It's like, okay, what's your null model? The one that I'm still less sure on, and maybe we need to have a discussion about as a community, is what's the null model for RMS error? So, you know, people are, I got an RMS error of 1.2 kcals, but what's the null? You know, what could I get from just guessing? So, I mean, the way that I've done this in the blind challenges is typically in the blind challenges, we're taking a subset of the data to use for the free energy challenges. So what I do is if there's 5 compounds there, I'll just go through and repeat like 1,000 times, just randomly sample 5 compounds out of that distribution and then use those as my predictions and then just look at what I get compared to that. I don't know if that's the best way to do it. it's something we should probably discuss as a community. But again, I'm troubled by people who just say, great, I got an Armis or of a kcal, and it's like, compared to what? So this is what we got from the first grand challenge from the 3 sets that we have. So you can see that just the null model is giving us somewhere around 1.8, 1.9 kcals. So I think we just need to think about what's better than a null. And if you take a look at the predictions, there wasn't a whole lot of difference in that challenge between the null and the median for the predictions. Just another thing that really bothers me, okay? And I've beaten on journal editors about this. Why do they keep putting all the supporting material as PDF? I mean, I've even seen it where like SD files are there as PDF, right? You can't get anything out. And you've got all this data and it's in a table in a PDF and I can't get it out and I can't do anything with it. So, if you have friends who are journal editors, please tell them to stop doing this. And really, when you're submitting your paper, insist on your data going in as a CSV file or something else, or better yet, don't put it in the hands of the journal. Don't let them screw it up. Just put it in a Git repository somewhere and reference that Git repository so that people can get it, Put your chemical structures in there as SD files or SMILES, and really enable the reader to do something with your data. This is what I do, right? I read a paper. The next thing I want to do is get that data and run it in my own method. And then this is sort of my last. I've been beating this drum for several years on reproducibility. I published this paper about 5 years ago, which I think was sort of, it was my Man of La Mancha moment. I think it pretty much had no impact whatsoever. But again, I think as reviewers, we need to insist on reproducibility. It's silly, right? And so how can I reproduce your method? I need your code. I mean, yes, a description of your method, that could be helpful, but to be honest, I probably don't have the time to re-implement your method, but I'd love to try it, okay? A web implementation of your method is useless to me. I work in a pharmaceutical company. I can't go put my data into your website. The other thing is, I don't really see it as scientifically valid, right? You're not enabling anybody to extend what you've done. So, code. So, these are a few things that are bothering me. I feel good having gotten some of this off my chest. Hope you do too. How do you help? So probably most of you are too young to remember Nancy Reagan, but be a responsible reviewer and make sure that people are putting the right things into their papers. I did want to talk just about, so sort of all that was around free energy scoring. So I also wanted to talk a little bit about docking, just a couple slides. So our docking challenges have definitely become more challenging. This last challenge, this one's really a really hard data set if you did it de novo. So you can see what we're doing is this is from, the first plot is the HSP90 data set from the first grand challenge. The second is the FXR data set from the second grand challenge. And then this is the results on the right from the Cathepsin S from the most recent challenge. So you can see that people did a lot better on the first one. I mean, the HSP90, the molecules were much less flexible. It was much easier. So, it's gotten harder, but I feel like we kind of need to go back and answer some fundamental questions here. And I haven't really seen a lot of this showing up in the literature. So it seems to me that there's a few reasons that we're going wrong with the docking. Are we just not getting the right confirmation? So when we do this and when we fail, can we just ask that question? Did the conformational ensemble that I generated did that have the crystallographic pose in it? Second question, did I sample that pose? Was it there and I just didn't score it, or did I just not find it? And then, if I did find the right one, where did that rank within these? And then, I really like the point that Nisa and Mill brought up yesterday about the electron density. So if I didn't find these, is it just because this was in a region that didn't have adequate electron density? I think another thing, and we brought this up, I think a couple of times at previous challenges, is it would be great if there was, I'd love to see a paper where two groups collaborated who had both submitted in the docking challenges. And, did you miss the same molecules? Did you get the same ones right? So, I think even more crosstalk. I love this meeting because it provides the opportunity for this. So, finally, I love these challenges. I mean, Nisha was asking me, why do you keep doing this? Sometimes I ask myself that. But, I think it's probably the most important thing that we can do as a community. This is what's going to push things forward, not, showing yet another wonderful correlation on a data set that spans 10 logs. I mean, that's not helping anybody. So, all of these challenges, D3R, CSAR, TDT, all of this sample has been great. I'm really appreciative to Romy and Mike for pulling all this together. Nisa and Mill for all of their analysis going into this. Sorry for throwing you under the bus for your slide. Connor and Zaid for all the work that they put in on all this, and then Schweid, who really put a lot of the infrastructure in place that made this challenge much easier than the ones that we've done in the past. And thank all of you for listening to me ramble on. David, did I come up with something quotable for Twitter? There you go. Let me see how much trouble I'm in. Okay. Yeah.
I agree with almost everything you said.
Almost.
What I wanted to see some input is on the null model. I think you made a great point that double electro when you do this quick thing with the paper model. But that quick thing you did, say, isn't that just the fact that it was fast doesn't make it a null model. I think I just want to say there are comparator models that we would use. So a null model is supposed to be a comparison of if I did nothing and what is nothing, like the standard error around just the normal mean standard deviation of data. You can do a simple model, but I think that's also very important to include. And I think that's something that the D3R could perhaps include as part of your challenges. You could say, we suggest we will be using the following null models to compare this, and that would trigger into perhaps recommendations to the field for different classifications of method, like we were talking about a scoring method. What would you do for like a confirmation?
Yeah. No, it's great.
Yeah, on that line, I was also thinking as you were giving your talk, which is terrific, by the way. Maybe D3R should think about having sort of a methods evaluation workshop, because when we are digging in on this data set, because there's a lot of questions, even for us,
Yeah, and maybe, before we even start, it would be great if we could all agree on this is how we're going to deal with greater than 10. And
so my one is that maybe, consensus paper, some sort of that. The other thing I was sort of wondering is whether, getting people to to apply these partly means making it easy. Do you think you could envision a page that would just have some text fields, you drop in your calculations, drop in experimental data, put in the experimental uncertainties, and then run through and give out two things. So we give out all the stats that are recommended by Pat Walters, and then maybe a CSV file that is in some consensus format that could be, and then the whole, it might not be that far.
Yeah.
Then we have Pat Walters format.
That's truly frightening.
That was a great rant. I would recommend you as a reviewer, could you maybe just do accept with major revisions instead of the reject, and we'll fix it. Going back to your docking, your ideas for docking, could you elaborate, like, if you had the perfect data set, what do you think the perfect challenge would be? How would you answer some of these questions, assuming you could get the data?
I think it's relative. I think a lot of this is relatively straightforward, right? Because you're generating, I'm assuming that your docking program is generating a set of conformers, and just check those conformers against.
So you want us to submit 1,000 conformers?
No, I just want you to go back after the fact and try to figure out why it didn't work, and explain to me, because I've seen, I mean, I edited the first JCA AMD, what is it? Yeah, the Terry Journal. I edited that first issue, and that was one of the things I had hoped to see more of. Was great, we didn't get the right result, and here's why. So just sort of using D3R as a way to debug your methodology.
On that note, too, something that projecting too much into the discussion, but something that Mike mentioned yesterday that I thought he was a little too nice on the community, but you mentioned again here today, is having participants and other people in the field, not just the D3R folks, really digging in on the evaluations of these submissions and the results, because there's really only so much bandwidth that we can do, that we have. I think the idea of multiple participants actually collaborating to dig in and figure out what is, what will be the next best thing for the methods is something that really needs to happen more than we're seeing.
So, I don't know if you can do this, but if there is, a journal issue where the participants will publish their claims, I strongly recommend that the statistics they publish are somehow clear with D3R or somebody, because I have seen case after case where the statistics that are actually in the D3R website and the notes that the authors publish do not agree with each other. You get R squares that suddenly magically increase. And that's actually the record, right? That's what people are going to go out and hype. So it would be really good if, say every R square that you post in your paper when you talk about the city, it's computed in some way.
No, I agree, and I think the other thing is, that's why when I review papers now, I insist on all of the data being there, because, if I have some other metric that I want to look at, I should be able to just grab your CSV file, read it into R, and, do whatever I want to do.
On the note of reproducibility with the code and kind of shoving scripts into a PDF, one nice thing that's started emerging that I think Codero would talk about, I'm surprised he didn't, but is making machine images using things like Docker. Where even if your workflow really is just a pile of scripts that run one after another, you can containerize that, you can send that to somebody else, and they can do it without the differences like a virtual machine on your computer. That might be a good thing to move towards as well.
Yeah, I love that.
Thank you for talking about products that this was being made. I've always been bothered by the fact that the correlation coefficients are so dependent on the data set, the dynamic range, and the kind of error that your method actually does have. So I wonder if we should start looking at these kind of statistics. So I still think that measuring the correlation on a very large dynamic range is valid. So I mean, it's necessary but not sufficient condition. So I wonder if we should start looking at these statistics as a function of the dynamic range. So we have a huge data set, and we can analyze the full data set and then slowly shrink the dynamic range and see how this range, and see if this so that we can actually differentiate methods that in which condition they actually are useful.
We have time for one more question. You can ask me.
Yeah, just a comment. For reproducibility, I think Jupyter Notebooks are the best way to make the data more reproducible. So I think like just quickly I could put like Jupyter Notebooks so use those as workflow. The workflow you put there and if those metrics and everything is available in Jupyter Notebooks we can use.
You mean just for analysis, like for exploring all the results?
Yes, yeah. So it's something like, okay, so I mean, Pat talked about like this, so I'll use all the metrics, right? Not just one metric. Okay, so you have all the metrics in the Jupyter Notebooks, so like, okay, whoever is coming up with a new algorithm, okay, you take it, you just put it, you fit it into that new notebook. And also, in when we're publishing, like, editors, they make Jupyter Notebooks as a requirement, so like, okay, everything is there. It's not just like something to put in a number, but it's all there.
I like that suggestion. Let's thank Pat again for a great talk.